Hello and welcome back to another Orange Coast College Mathematics video. In this video we're going to talk about the difference quotient. Now, what exactly is the difference quotient? Well, the difference quotient is going to be this formula right here. But what exactly is that? How did we even get this formula in the first place? To answer that question, I want to remind you, typically we refer to a function as y equals f of x. Now, what does that mean? That's saying that my output, right, my y value, is equal to a function where I plug in an input, my x value. Now, behind the scenes, this equation is actually a little bit different. Technically, this equation is f of x plus h minus f of x divided by x plus h minus x. Now, let's get an idea of what this is actually saying. To do that, I'm going to draw a graph. Okay, so I've got myself some graph, and I want to label a couple of things. Let's label this point that I just circled in blue. So what is its x value? Well, I don't know the exact x value, but I can label it as x. But what is this point's y value? Well, how do you get a y value? You plug your input into the function. And so my y is equal to f of x. So I can call this y value f of x. Now let's look at this other point. What is its x value? Well, its x value is going to be somewhere down here. But how do I label that? I could label it x1 or x2, but instead I want to write it in terms of this blue x. What is the distance between the red mark and the blue mark on the x-axis? Well, I'm going to label that distance as h. So we can write this red tick mark on the x-axis as x plus h. To show that this makes sense, let's pretend that this blue x is a 3 and that this red tick mark is 5. Well, I can rewrite 5 as 3, my original x, plus 2. So in this case, h would be equal to 2. So I can rewrite this red coordinate as the blue coordinate plus a distance h. So what is the y value of this red point? Well, it's going to be f of x plus h, right? How do you get a y value? You plug the x value into your function. So now let's go back to our equation and look at things in a different lens. The numerator is f of x plus h minus f of x. But what is that? This is saying the y value of my red point minus the y value of my blue point. It's the difference of y values, or delta y. Now let's look at our denominator. We have x plus h minus x. And what is that? Well, this is the difference in x values, or delta x. So really, our difference quotient is actually delta y over delta x. You may be more familiar with this in terms of rise over run, or even more so, as slope. This is the slope of a line. Well, which line are we talking about? It's going to be the line connecting these 2 points. The secant line. So the difference quotient is really just the slope of the secant line. So f of x plus h minus f of x divided by h really is just equal to the slope of the secant line. Which really is just the line connecting 2 points of a function. we are supposed to find the difference quotient of this function. So let's go ahead and write our formula. So f of x plus h minus f of x, and then all of that divided by x plus h minus x. The goal for this is we're going to plug in each of these inputs into our function, and then hopefully something nice pops out. So let's figure out what f of x plus h minus f of x is. So, what is f of x plus h? Well, looking at our function f of x is equal to 2 minus 5x, I'm saying that my input right here, I'm going to take that input and plug it in right here. So wherever I see an x, I put in an x. But in this case, our input is actually x plus h. It's not just x this time. So wherever I see an x, I'm going to plug in an x plus h. So f of x plus h is equal to 2 minus 5 times x plus h. Now we'll do the same thing for f of x, but we're plugging in x, so nothing really changes. The only thing we ever have to worry about here is that we need to make sure that this negative sign applies to the entirety of f of x. So I find it easiest to just put f of x in parentheses and subtract the entire thing. That way I'm not going to accidentally apply my negative sign to some pieces in the numerator and not others. Now all of this is divided by x plus h minus x. But what do we see here? We have x and we have minus x. So these two pieces are going to cancel out. And what are we left with? Just h. So our formula takes this into account already, so we don't have to do this step over and over and over again. We just leave it as h. So let's continue with our problem and try to simplify things out. So this is going to be 2 minus 5x minus 5h, and then I'm going to distribute the negative sign to the 2 minus 5x, minus 2 plus 5x. And then all of this is divided by h. Now let's look at the numerator. We're actually going to have a few pieces that cancel out. What do I see? I have a positive 2 and I have a negative 2. So those two are going to cancel each other out. What else do I see? I have a negative 5x and I also have a positive 5x. So those two are going to cancel each other out. So what am I left with in the numerator? Just a negative 5h. So our equation becomes minus 5h divided by h. Well, conveniently, I have an h in both the numerator and the denominator, so those two are going to cancel each other out. And so my final answer is just going to be negative 5. So let's move on down to the next problem. It's always good to start off by writing your formula, so let's go ahead and do that. So f of x plus h minus f of x, and then all of that divided by h. So in red, x plus h is my input, so everywhere I see an x in my function, I put x plus h instead. So this becomes x plus h quantity squared minus 3 times x plus h plus 1. Now I'm subtracting f of x, so I'll put a minus sign and then parentheses, and then just rewrite f of x. So x squared minus 3x plus 1. And then all of this is divided by h. Let's go ahead and expand some terms so we can try to simplify. So the numerator becomes x squared plus 2xh plus h squared minus 3x minus 3h plus 1 minus x squared plus 3x minus 1. And then all of this is divided by h. Now we can look for some things that cancel each other out. So first off, I have a positive x squared right here, and I have a negative x squared right there. So those two are going to cancel out. Then I have a minus 3x right here, and a positive 3x right here. So those two are going to cancel out. And finally, I've got a positive 1, and I've got a minus 1. So those two terms are going to cancel out. I'm left with 2xh plus h squared minus 3h, and then all of this is divided by h. Now what do I see? In my numerator, I have an h in every single term, so I can factor it out. So this becomes h times 2x plus h minus 3, and then all of that is divided by h. Well, conveniently, I now have an h in the numerator and an h in the denominator, so I can cancel them out. So my final answer becomes 2x plus h minus 3. Moving on to our last problem, let's go ahead and rewrite our formula as always. F of x plus h minus f of x, and then all of that divided by h. So in the red, everywhere I see an x in my function, I'm going to plug in x plus h. So this becomes 1 divided by x plus h minus 1 over x, and then all of that is still divided by h. Now in the numerator, I have two fractions, and they don't have the same denominator. I want to combine these two, so I need to make sure that they have a common denominator. How can I do that? I can multiply by 1 in a creative way. As in, I can multiply by the two denominators multiplied together divided by themselves. As in, x plus h times x divided by x plus h times x. So what am I doing right here? Well, what is the value of this? The value of this thing that I'm multiplying my numerator by is 1. And multiplying by 1 doesn't change the value of our answer, but we're multiplying by 1 in a creative way that is allowing us to rewrite our function to have a common denominator. So let's go ahead and multiply everything out. So the left side is going to become x plus h times x divided by x plus h times x plus h times x. Then the right side will become x plus h times x, all divided by x plus h times x times x. And of course, we can't forget about our divided by h at the end. But let's go ahead and see what happens. In the red, I have an x plus h and an x plus h right here, so I can cancel those out. And then in the blue, I have an x and I have an x right here, so those two can cancel out. So what am I left with? I'm left with x divided by x plus h times x minus x plus h divided by x plus h times x. And of course everything is divided by h. But let's take a closer look at our numerator now. Both the red fraction and the blue fraction now have the same denominator. Since they have a common denominator, we can combine them. So this becomes x minus h. Right? You need to be careful because this negative sign will apply to both pieces in the numerator, divided by x plus h times x, and then this whole thing divided by h. Well, let's look at the top. We have positive x and we have a minus x, so those two are going to cancel each other out. So this becomes negative h divided by x plus h times x, and then all of that divided by h. Now, anytime I have a fraction divided by something, I can rewrite it by multiplying by the reciprocal. So I'm going to rewrite h as h divided by 1. So this becomes negative h divided by x plus h times x times the reciprocal, which is just the bottom fraction flipped. So this will be times 1 over h. I have an h on the numerator and an h in the denominator, so those two are going to cancel out. And so my final answer is going to be negative 1 divided by x plus h times x. That's going to do it for this video, and I hope to see you in the next one.